All right, so let's go ahead and get into this. In chapter 5, we're going to be talking about discrete probability and distributions. 5.1 is probability distributions. So objective 1, we're going to construct a probability distribution from a random variable. So let's go over some vocabulary that we've already technically seen. A variable is a characteristic or attribute that can assume different values. This is not a new one. This is the same as chapter 1. A random variable is a variable whose values are determined by chance. Discrete variables are variables that have a finite number of possible values or an infinite number of values that can be counted. I remember discretes like 1, 2, 3, like you can actually count the numbers. If it's listed, yes. Like you can actually count how many numbers you have. It's more of your finite. All right. Variables that can assume all values in the interval between any two given values are called continuous variables. So this would be the ones that are like 1.1, and then between that is 1.01, 1.001, 1.0001, and all those different ones. So this is continuous variables. That there's basically no values in between all your variables and uncountable. You won't be able to count all the variables that are in it. Continuous random variables are attained from data that can be measured rather than counted. So this is like your height, volume, weights, things like that. Yeah. Yeah. Numerical? Numerical, nominal. Nominal would be qualitative. So continuous and discrete is for quantitative. So nominal and ordinal would not be in that. It would be your ratio and interval. But both of those can be discrete or continuous. It's a review from Unit 1. Yes, sir. Yeah, all this should be new, not new to y'all. All right, so probability distributions. So a probability distribution is a process that leads to well-defined results or outcomes due to chance. A discrete probability distribution consists of the values which a random variable can assume and the corresponding probabilities of the values. And the probabilities are determined theoretically or by observation. So what basically should happen or what do we see happen, right? So no subjectiveness. All right, so let's look at example 1 here for example based on theory. So probability distributions for tossing 3 coins. Construct a probability distribution for a discrete random variable using a probability experiment of tossing 3 coins. Kind of like what you just saw in your tests. So if we toss 3 coins, we can see, especially if we look at our tree diagram, you can see all the 8 possibilities that we have. So you have a probability of no heads, 3 different ones that have 1 head, 2 different ones that have 2 heads, and then 1 with 3 heads. X would represent the number of possible head outcomes, so 0, 1, 2, or 3. And then here's our probability. There's 8 different one of them, but how many do I have a probability of getting no heads? You have 1. You have 1 option out of 8 where you don't get a heads. How many options for each one of these gives me, so like for instance, what's the a probability of getting tails, tails, heads? 1. Probability of getting tail, heads, tails. 1. Probability of getting head, tails, tails. 1. So 1/8 plus 1/8 plus 1/8 gives me 3/8. The same concept over here. There's only 1 there. So same process here to get 2 heads. What's the probability of doing head, heads, tails? Copy, paste, heads, tail, hill, 1. Tail, heads, heads, 1. Add the 3, and you get 3. Probability of getting 3 heads, 1. So it just stays 1. Now notice, what's 1 plus 3 plus 3 plus 1? 8, because it has to total up to 1. Again, another test question. So we're going to take that and we're going to plug it into our chart. No, you can just keep them as the fraction. So what was our probability of no heads? Probability of 1 head? Probability of 2 heads? 3 heads. Perfect. Questions on how to fill out these charts? All right. So if asked again on the final exam, we're going to say that there's a sample of 8 in there, right? Yes, not 6. Maybe. Maybe it'll be a free response this time. Yeah, y'all like the setup so far? True, false, multiple choice, and free response questions. Yeah. It's just there's so much vocabulary in here. It's hard to make those free response questions because then I'm like basically asking for the definition, and then that's rogue memory. I'd rather you just be able to tell me, all right, is this true, false? Do what? Oh, multi-match or multi? Yeah. I'm not a big fan of those. No, well, it's not that you're guessing. You can guess, or you can figure out like half of them and then guess the other half by process of elimination. Ooh, I like how you brought that in. All right, so there we go. So this one is we're going to construct a probability distribution for rolling a single fair die. So this is not a weighted die. A die has 6 sides and we'll number them 1 through 6. And we're going to write out the outcomes for each probability. So what's the probability that you get a 1? 1, 6. What's the probability that you get a 2? 1, 6. What's the probability that you get 3? 1, 6. Probability of getting a 4? 1, 6. Probability of getting a 5? Probability of getting a 6. What does that all total up to? 6, 6, which is just 1. Very good. Any questions so far? Real hard. So let's do an observational probability here. So number of World Series games. So this is something that's already happened. So this one says the Baseball World Series is played by the winner of the National League and the American League. The first team to win 4 games wins the World Series. In other words, the series will consist of 4 to 7 games, depending on the individual's victories. Basically, you win best out of 7. That is shown consists of 40 World Series events, and the number of games played in each series is represented by the variable x. So find the probability for each x and construct a probability distribution. So for the 40 World Series, include the winner. The winner was determined in 4 games 8 times, 5 games and 7 times, 6 games 9 times, and 7 games 16 times. Real quick, what does 8 plus 7 plus 9 plus 16 total up to? 40. Make sure that all does work out for you. Because that's 25, then that's 32, then 40 right there. So probability then that they got, they won in 4 games. 8. So this becomes 8 out of 40. And if we type that in the calculator, what do we get as a decimal? Good. So that'd be 0.2. All right. Probability of getting 5 games. 7. What's that one? Close. 0.175. 0.18 is really good. Probability of getting a winning in 6 games. Well, what's the first number? How many times did that happen? 9. All right. So 9 out of 40 would be what? No, I did. I just said 6. How many times we win 6 games? No. How many how many times did we win in 6 games? 9 times. Good. What's the probability of winning it in all 7 games? Sometimes I wonder if they do that on purpose to keep the ratings up. Like, all right, I need you to lose this one. Make it to game 7. I think it's all conspiracy. I feel like sometimes sports is like wrestling. It's all someone paid to win. Yeah, that's it. Either way. So 16 out of 40 is what? Very good. Double that. So double this. What does that all total up to? It does equal 1. That's 0.6. This right here actually ends up being 0.4. 0.6 plus 0.4 is 1. All right. Any questions on how to make a chart? All right. We'll keep going. Tomorrow. We'll keep going tomorrow.